Hello everyone. This session is about Kubernetes pod controllers. Okay, so my main goal of this video is to make your understanding of pod controller clear. Okay, so before like even explaining what are pod controllers, I want to first show you the problem without controller. Okay, so what we do now, we will move to a killer coda. So people who are not aware of Killer Coda is actually a browser-based platform that provides you an interactive learning environment to practice Kubernetes, and it is completely free of cost. Okay, so what we do now, first I will create one pod. Okay, let me copy the example to create a pod, and all the example links I have given in the description in this video. Okay, I will give name as sample pod one dot YAML. Okay, and paste the content. Have a look what we are doing. We have a kind pod and we are creating a pod name is sample, and we are using the nginx image here, container port 80. Okay, fine. So key apply minus f sample pod to YAML 5. Okay, get pod minus w. So you can see a one pod is up and running. Till now we are fine, like we have a pod which is running. But what are the problems here when we create a plain pod? When you create a plain pod, one of the problem is we don't have an option here to create a multiple instance of the pod. Let's say you want to create a 3 instance of the pod. Let's say because the reason like you want to distribute the traffic into multiple pods, okay, for higher performance. But when you create a pod like this, you don't have any option. Even Kubernetes itself will not provide you an option here. Okay, the second thing is this pod doesn't have an option to ensure that pod will automatically recreate it when we delete it. We have a pod which is running. Let me delete this pod. Okay, delete this pod, paste the name of the pod. I have deleted this pod now. Now if I do the get pod, you can see we don't have any pod available. No resources found. Okay, and also we don't have any option to scale up and scale down the pods when we create a pod this way. Okay, so at this stage, don't you feel we need some tools to manage and control these pods? And that's where Kubernetes controllers comes into the picture. So what are Kubernetes pod controller? I'm specifically telling here a pod controller because there are other Kubernetes controller as well. Controller to manage services, controller to manage ingresses, network policies and all. So in this session, what we are talking only about pod controller, the controller which controls the pods. Okay. So the definition, the simple definition, what we can say, Kubernetes pod controller are the tools that monitor the state of your pod and make changes whenever is needed. Okay, so what I will do now, there are slides to explain the controller further, but I want to show you how controller works practically once. Then we will come back to the theoretical explanation again. We will move again back to killer coda. Okay, so what we do now, we take an example of ReplicaSet. I have given this link also in the description. ReplicaSet is one of the controller. Okay, we take this, we create this controller and see how this controller is managing the pod. Okay, vim replicaset dot YAML file, paste, insert. Okay, and we'll just have a look what we have given. Previously we had given a name as kind as pod. This time we are giving a kind as replica set because we are not creating pods here. Okay, replica set itself will create the pods. Okay, the name of the replica set is we have given here. Then this is how here you can see the line number 8 replicas. We have given total replicas count as 3. So what we are telling this controller, replica set controller, what we are telling, okay, we are telling controller that okay, you should always maintain 3 instances or 3 replicas of this pod. Okay, and again this pod is having image nginx and it is having one pod. Okay, let's create it. Let's create it. k get pod minus review. You see, 3 pods are running now. Who created these 3 pods? The replica set is created these 3 pods. Okay, and what we can do now, the 3 replicas of same pod is created. What we will do now, I will delete one of the pods. Let's say the number F71. This is the pod which I will be deleting now. I have deleted this pod. Okay, let me see how many pods we have now. We still have 3 pods. So what happened is, you can see there are 2 pods started 33 seconds ago. They are older pods, and there is one new pod which came just before 3 seconds. So what happened at this stage is, when we deleted this pod, okay, when we deleted this pod, the ReplicaSet controller detected that event and they recreated the pod again. Okay, so they recreated new pod again. So you can see this new pod name JRJ9 something. So that's how the controller manages the pod. So not only this stuff, controller does so many other things. We will be knowing that in our further slides. Okay, we'll go back to slides now. So what are the main tasks of controllers? One, the controller ensures that a desired state of pod is maintained. What is desired state? Like, I have given a replicas as 3, right? That's the desired state. So our controller makes sure that our system always have those many pods up and running. Okay, and scale up and scale down. Okay, based on the specification. Okay, for example, here we can give the CPU percentage. We can give the 60%. When it reaches to the 60 percentage, then you bring up one more pod. Okay, so we have given min and max as 2 here. Min is 2, max as 10. It means that it can scale up the pod up to 10 instances, and when it goes down to less than 60%, it will bring down one until 2 instances. So this auto scaling also is managed and controlled by the controller. Okay, and reschedule the pod on different node in case of node failure. Let's say in master node and worker node, when we have one of the node itself will get fail where multiple pods are running. So this controller will create new pods into the another VM which is healthy. Okay, and manage rolling updates, rollback of pods. This I have explained in my previous video, and clean up the terminated pods and their resources. So all these activities are done by controller. And how many controllers we have? We have different controllers are which are used and applicable in different scenarios. Okay, so different controllers list. What we have is a replica set, which we just saw, deployment, stateful set, DaemonSet, replication controller, CronJob, and job. So these are the pod controllers we have. So yes, so I will finish this video now, as my main goal was to make your understanding of controller clear first. Okay, when someone asks you what are controllers, so then you should be able to visualize the what controller is. Okay, now in the next video and in the upcoming videos, I will be covering each individual controller in details. Okay, so this video we talk about the controllers in details. Okay, we'll start with the first controller, that is the replica set controller. So what is the replica set controller? In simple definition, it's a controller that ensures a specific number of identical pods are always running in the system. Let's say you have created a replica set with 3 replicas, then it will always ensure that okay, 3 replicas of that pods are running in the system. And if you delete any of the pod, it will recreate. If any of the pod gets failed, then also it will remove that failed pod and recreate a new pod. So that's what the job of the replica set. And along with it also help you to do the auto scaling. And like say, let's say you have 3 pods. If you want to make 5 pods, you can increase the count of the pod as well. Demo of the replica set I have given in my previous video. The link is given below. You can check it out. Now there are some features which are not present in the replica set. One of the feature is rolling update of the version change. What are rolling update? It's the process of deploying new image to the pod without or with minimal downtime. Like the running pods, the current traffic into the system should not get affected. This is the mechanism what we call as a rolling update, and that video also I have given in the description. I have already prepared a video on rolling update. You can go through and understand what is rolling update. And similarly, when you perform the rolling update, you may require to go back to previous version if anything goes wrong. Even that option is not available in the ReplicaSet controller. And there are some of the deployment strategies. If you see my previous video, you will see I had explained you what is rolling update and all, what is rollout, rolling update and all, and different types of rolling update strategies what we have. This support is also not available in the ReplicaSet. Kubernetes have came up with another controller called deployment controller. Okay, I I will tell you like more detail about the deployment controller. What we do, we go to our demo section, we'll create one deployment controller, and we'll come back to slides again. So I have a killer coda session running here. Okay, I have this link of this example also I will give in the description. You can copy the content or you can create your own deployment also. Okay, what we do, we'll create a deployment file, deployment.yaml file I will create. I already have it one. Deployment1.yaml. So if you see, the file content looks similar to replica set. Thing like kind previously it was a replica set. Now you can see it's a deployment, and total replicas we are creating from this using this deployment is 3 replicas we are creating. So before that, let's check whether we have any pods running. No. Do we have any replica set running? No. Do we kubectl get deploy command to check if there are any deployments are running? No. Okay, we apply now. Apply -f deployment one.yaml file. Now you see kubectl get pod, 3 pods are running, and the beauty of the deployment controller is it automatically creates the replica set also. And actually, these pods are created by the replica set, which is created by the deployment. Okay, kubectl get replica set I will give rs. You see there is a replica set is also created here. kubectl get deployment. You see there is a deployment. So what is happening whenever you create a deployment file, deployment resource, deployment is a resource. Wherever you create a deployment resource, it will internally creates a replica set, and that replica set creates the pod. So whatever the functionality of replica set, all the functionalities are by default present in the deployment. Okay, and deployment is having some of the additional feature as well. Okay, and you can see the naming convention if you want to identify in the feature like which how you can relate this pod belongs to this deployment. You see the name of the deployment is nginx deployment, and what is the name of the replica set is created? Nginx deployment, then a random screen, a random number. What is the name of the pod? Get pod. Nginx deployment, name of the deployment. Then if you see this is the name of the replica set, then there is a random string. Okay. So what are the extra features what the deployment is supporting? One is a rolling update. Okay. Rolling update video I have already provided in details. Okay, you can check it out. Okay, and roll back to previous stable version. That is the beauty of the deployment controller. Like if you have upgraded a pod with particular version, and let's say for some reason you want to roll back to previous version, this deployment controller maintains that history. You can easily go back to, in one click you can go back to the previous image. Okay, version history tracking management, automated scaling and scaling down, scaling up and scaling down, and automatically creation of replica set, and several other features like max search, max unavailable, custom deployment strategies, which you understand in depth while we study rolling updates. So okay, all good so far, but there is something which we need to observe here: the names of these pods. Okay, if you see, each pod has unique string appended at the end. Correct, unique string appended at the end. For example, I have 3 pods here. Let me delete one pod. Delete pod. Let me delete this pod. Copy, paste. Okay, so I have deleted this pod, and now if you see, pod got deleted. If I do get pod again, you see the new pod is created. That pod which I deleted, the ending with LR is gone. 85 a new pod came up. Okay, but this pod is also having a unique string which is not matching with the previous string. Why? The reason, because deployment controller works only with stateless applications. Okay, only works with only stateless application, and if you want to run stateful application, then we need another controller which is provided by the Kubernetes, and both are required, depends upon your use cases. So I will prepare a next video, and in that next video, first I will explain you the difference between the stateless application and stateful application. Then I will tell you why deployment cannot be used for stateful application. Then we can discuss the controller used for stateful application. Okay, so that's all in this video. I hope you like it. Please like, subscribe, and comment if you have any doubt. Thank you very much.
Let us now try understanding the difference between stateless application and stateful applications. Stateless applications are applications that never keeps any information from one request to use it in the next request. Okay, each request is handled independently, and any new request processing does not rely on the data of the previous request response or previous transactions. Okay, for example, what you can see a example of candy vending machine. Okay, and what you can see, you put the money, you press the button, you get the candy, and that completes the one transaction. And if you want more candy, you put the money, you press the button, you get the candy. To serve you the candy second time, it does not rely on the data which they acquired, or which they do not need to store, use the data from the previous request. So that is what the stateless application, which doesn't maintain any of your data to serve a new request. Okay, another example is a weather APIs, a website providing weather APIs. Okay, so what we do, we we directly go to one of the website who provides the weather information, and let us see. Here it is showing the weather of Kolkata. What we do, I will search for Delhi. Now it is giving the weather of Delhi. I will search for Bangalore weather. It is okay. It will give you the weather of Bangalore. Now the thing is, like, to provide the weather of Bangalore here, it does not rely on what I had searched before. Okay, previously I have searched for Kolkata, I have searched for Delhi. To serve any new request, it does not rely on the what I have searched before. So it means there is no continuation between these transactions. Okay, they are completely independent transactions. So such applications are called stateless applications. Okay, so to serve any of my requests, no user information is stored, no session information is stored, and every request is served independently without storing any data. Now we try understanding what is the stateful application. In contrast, stateful applications are applications where information from one request to use, like applications that retains the information from one request to use it in the processing of next request. Okay, each request may rely on the data what they acquired in the previous request. Okay, so every request response is a same, it's a part of same session. Okay, so such kind of application what we call a stateful application. Okay, one of the example is video conferencing application, where it is not just like a request and response. What happens in a video conference is one user who hosts a conference meeting and other user join using an invite link. Then the backend application maintains the details of the meeting so that it can serve multiple user coming, going, joining, unjoining, mute, unmute, and several things. And that is the kind of application what we call as a stateful application. And another example is a gaming app we have. Okay, so what I do, let's go to one of the online gaming platform, and we'll see how it is maintaining the session. Okay, let me go here. I will play this app. Okay, what is happening in the background. My session got created now because I have got some 30 bullets to use. I have got some bank strength stats. I have got some timer started here, some cash balance. All these things are stored, and my every action changes this value. For example, let me hit this person and you can see my bullet count is getting reduced. So how it is getting reduced? Because this session, because the application who is where I'm playing this game, they are storing my previous data. I'm moving from this location to this location, so this information is stored. My bank balance information is stored, my timer and all the information is stored. So these are the kind of application what we call as a stateful application. So stateless applications are the one that doesn't store any of the user data, because it's like a single transaction. You send a request, you got the response. A stateful application, it's like a continuous session, okay, where every new request, every request have some relation with the data which what the server acquired in the previous requests. Okay. Yeah, this is about stateful application and stateless application. Hope you understood this. Okay, then now, as we understood the difference between stateless application and stateful application, now let's try to put the same example into deployment architecture and see how it fits into this. Okay, so we have seen one example related to weather. I have a separate video also explaining stateless application and stateful application. You can watch that video as well. I have given that link in the description. Now what we do, this weather API application will try to put this into this deployment architecture. This is the typical deployment architecture. When we create the deployment, it internally creates the replica set and it creates the 3 pods, pod 1 and pod 2 and pod 3. You can see a random string appended at the end. Okay, then to give the access to this pod to the external world, means any user wants to reach to this pod, there is a service created in the backend. We call it as a load balancer service, and the job of the service is to automatically distribute the traffic among all the pods. Okay, and it distributes the traffic in round robin. The default behavior is it distributes the traffic into the pods in round robin fashion. Okay, so what we do now, we try to fit that example into this. Let's say a user wants to know the weather of Bangalore. Okay, he will send the request to load balancer. Load balancer, let's say, gave the request to pod 0. Pod 0 communicated with the database, got the result, and send it back to the user. And now there is a new request coming, like a user wants to know the weather of Delhi. Request will come to load balancer, goes to this pod, goes to database, and user got the response. He wants to know the Kolkata result. He will send a request here. That request will go to different pod now. He will communicate to the database, get the response, and serve it. So if you see, load balancer can forward the request to any pod, and any pod is able to serve the request, because none of the pod is maintaining any dependent data here. Like first request can come here, second request can come here, third request can come here. Since there is no relation between, or there is no continuation or session data is required to serve a new request, so any pod can independently serve this request. Okay, now what we do, we saw one more example, right? We saw this example of StatefulSet, where we create the game, and that game will have my balance, okay, my points, how much of bullets I have, and all my movement, all the information the session stores. This is the example of stateful application. What we do, we try to put this example also into the deployment architecture and see whether it fits into this or not. Okay, the deployment names are weather API here. Actually, assume that this is the game API only. Okay, what we do now, let's say user will first come to the website and create the game. So let's say that request come to the load balancer randomly forward that request to assume this pod. So what happens, a user session will be created in this pod. Okay, so he created the game, and game session is created in this pod. Okay, next time let's say user did a mouse click. Okay, that request came to the load balancer, and that request load balancer can forward that request to any pod. Let's say load balancer forwarded that request to this pod. Now, this pod doesn't know any information about this game session because it's in the local storage of this pod. Okay, so this pod, when it creates the game, it maintains a local storage for his current balance, his total points, total energy available, bullet balance, and everything that is available in this pod. If next request to update the balance or something comes to this pod, then this request will not be served. It will be rejected, and that's how we lost. We will lose our entire communication here. So this shows that the stateful application where stateful application who maintains the local storage cannot be fit into deployment architecture, because in the deployment architecture, service will randomly forward the request to any pod. And you may say, skipping the service, how about sending the traffic always to this pod? These pods have a random names. They don't have a constant name as well. So if by any chance, if we restart this pod or if this pod got crashed, the name of the pod itself will get changed. Okay. So the reason Kubernetes have came up with a controller called stateful controller, StatefulSet controller. So now we talk about the StatefulSet controller and we see how it works. Yeah, let's talk about StatefulSet controller now. StatefulSet controllers are controllers that are specifically designed for managing the stateful applications. Okay, and here each pod will have a dedicated storage because it has to store the data, and there is a DNS host name pointing to each pod directly. Okay, I will take you to the architectural diagram. In system, when we deploy the StatefulSet controller, so this is how the typical architecture looks like. Okay, we will have pods deployed here. Each pod will have a dedicated storage attached. Okay, you can see the pod name and the storage name PVC. Both are having game 0, game 1, game 1, game 2, game 2. Okay, and you can see here one more. You can observe, like in deployment, we always had a pod ending with random string, but in StatefulSet, we will not have a random string pod, because each client who communicates to this pod, he use the name of the pod for the communication along with one service URL and attaching name of the URL. So this name of the URL should not be changing. Even if you restart the pod, name of the pod will not change. Okay, and even this storage will have the reference of this name only. Okay, we will look into the one demo, and yeah, along with storage, we need to have one service, and this service actually is kind of headless service, or we don't really communicate to this service, but we will use this service to form a URL to communicate directly to the pod, which I will show you the example. Yeah, we will go to Killer Coda again, and we'll take the examples from my GitHub link. I have given this link also in the description. What we do, first we will create a stateful set. Let's check, do we have any storage running already? No. Do we have any pods? No. Okay, do the vim and take this file sts.yaml. Okay, at high level, what we are doing in this pod, kind is a stateful set. Okay, and number of replicas we have given a 3. We have given 3 replicas. Okay, and here one thing, other parameters are almost common, like we have given the label as njnx, which we will use it in a service. You can see we have created a volume claim template that is for 1 GB, and this volume claim template we are attaching to the container here. Okay, if we have 3 pods, every pod will have this volume created, and that volume is attached to this path. And if we have 3 pods, then 3 such volumes will be created. Okay, Let us deploy this pod. A get pod minus W. Let the pod, all the pods to come up. Yeah, till the time as we are telling, we need a service also here to establish a communication towards the pod. I will, that code also I have given in the description. So we have all the pods running. You can see the names of the pod as nginx0, nginx1, and nginx2, not like the random string names. And since we have created the 3 storages, right? Get PVC. When we give the get PVC, you can see the 3 PVCs are created and 3 PV also, persistent volume also got created here. And you can see each of every claim has the name, pod name attached here. Means this storage is dedicated to nginx0 pod, this is dedicated to nginx1 pod, and this is dedicated to nginx2 pod. Even we can describe this PVC, describe PVC. You can see this PVC is used by nginx0. Okay, now let's create a service to establish. Then we will see how we can communicate to this pod. svc.yaml. Okay, I have given the here the reference selector as app nginx, which was present in our StatefulSet application. K apply minus f svc. Get svc. Now the service is also got created. K get pod minus oy. We will see the, like, we have 3 pods. Now we will see how we communicate to this pod. I give the pod name here. We'll go inside the pod actually. Okay. So I'm inside the nginx pod. So what I will do, I will use this name to communicate to the pod. Now, this is the URL I ping. I got the IP of one pod. I will communicate to nginx0 pod now. I got the IP of the pod. I will communicate to nginx2 now. You can see the 1.9, that is actually a nginx2 IP address. Okay, so how this URL is formed? Then first the name of the pod. Okay, first it's a name of the pod, that is nginx2, then the name of the service, then name of the namespace, then there is a common string called svc local.cluster. This is actually a direct URL towards the pod. Okay, the client will use this URL to communicate directly to the pod. The client will have that application logic how to always communicate to this particular pod only. Like, let's say it received the first request, then it will create some session ID and it will create some mapping internally that whenever I have a request with this session ID, I have to forward this to pod 0. Then this session ID pod 1. Then this session ID pod 2. That's how it maintains the data. The client application maintains the data and communicate to their respective pod only. So this is about the StatefulSet controller. Let's now talk about the DaemonSet controller. DaemonSet controller is actually a kind of special controller which actually ensures that a copy of specific pod runs on all the nodes in the cluster. Okay, this is the, for example, if you look at the typical cluster architecture of Kubernetes, it will have a master node. It will have a master node, then it will have several worker nodes. Each of the worker node will be serving several pods. Okay, several pods are deployed here, several pods are deployed here, several pods are deployed here. So so what we want is, let's say we have a requirement like every node, every worker node should have a log monitoring server deployed. Okay, that is the requirement we have. In such case, we use the DaemonSet controller. So we configure that pod which has to be deployed in a worker node, and it will make sure that that pod is automatically deployed in every worker node. Okay, for example, let's say we have a log monitoring pod. For example, let's say there is a Fluentd is a log monitoring pod. FluentD log monitoring pod. When we configure FluentD to be deployed via DaemonSet controller, then what it will do, first it will deploy pod in all the worker nodes. Okay, FluentDT here also, one of the pod of FluentDT here also, one of the pod of FluentDT it will deploy here also. Okay, let's say tomorrow we are introducing one more worker node. Okay, one more worker node we will bring up tomorrow, one, let's say worker node 4, then DaemonSet controller automatically deploy a FluentD pod here as well. Okay, so let's say tomorrow for some reason we are removing this node, then from the DaemonSet internal state maintenance it will remove this information about this FluentD pod as well. So the main job is simple, that every worker node should have this pod. When we have such kind of requirement, then we need to use the DaemonSet controller. So we have covered almost all of the controllers: ReplicaSet, deployment, StatefulSet, DaemonSet, stateless application, stateful application. We have left with a few more controllers. Okay, let's talk about them. Okay, one we have is a replication controller. It is similar to ReplicaSet. Its job is to maintain a specific number of pods are always running, but it's a legacy resource. Okay, part of early Kubernetes, and ReplicaSet is introduced as a replacement of replication controller. So people do not use a replication controller nowadays. So we don't need to worry much about this controller. And next we have jobs and CronJobs. Actually, they are not controllers. They are kind of pods actually, which bring up the pods for certain tasks. Once the task is completed, the pods will be terminated. Job is what? It's in job in Kubernetes. It's used to create one or more pods to perform some specific task. Once the task is complete, pods are terminated. For example, before we perform, for example, we want to do some configuration, we want to do some database update, we want to do some connection checking. For such kind of tasks, we will create a jobs which perform some task, and pods will be terminated immediately. What we have is a cron job. Cron job is actually similar to job only, but only thing is cron job will come up at specific time or interval. Then they perform some job and pods will be terminated. For example, you want to take the backup of a server every day at 10 p.m. Then we will schedule a cron job here. So I think that's how we have covered all of the controllers. By summary, if I want to summarize, ReplicaSet, which ensures that number of pods are always running in all the times. Okay, we have a deployment which actually manages the ReplicaSet as well, and deployment is ideal for stateless application. Okay, and we have a StatefulSet, ideal for stateful application. When we have if you want to use the stateless application, go for deployment. If you have stateful application, go for StatefulSet. Okay, and DaemonSet is the case when you need to run a copy of pod on all the nodes in a cluster, such as for logging, monitoring, or networking tasks, then you can go with DaemonSet. So that's all about the controller. Please let us know if you have any doubt regarding these controllers. Like, share, comment, and subscribe. Thank you very much. Take care.